All right, so lesson 3, we go into factoring polynomials, which is the foundation of the entire unit, and we'll use it in several units moving forward. So really make sure that you get a solid grasp on this. The biggest thing for today is make sure that you factor completely. So factor till all factors are prime. And remember what a prime number is, a number that's only divisible by 1 and itself. Prime factors are the same way. Nothing should go into um, each of the terms except 1 in itself, and we can't break it down any further. So the first step to every factoring problem, every single factoring problem, is your GCF, which is what each term has in common. And you're going to do this first, no matter what. Okay, so your first step to every factoring problem is your GCF. And so that's just looking at like something like this and saying, okay, well, 6y squared is a term and 3y is a term. Terms are separated by addition or subtraction. And the GCF for those two terms is 3y. So we're going to take out that 3y, or undistributed, or you can think of it as dividing by 3y each time. Only it doesn't like divide away. We don't have two sides of our equation. And so we take 3y to the outside of our parentheses. And we've done problems similar to this when we did literal equations. So here they are again. So inside your parentheses, you should have the same number of terms as you started with. So you start with 1, 2, you should have 1, 2, and then outside whatever you took out. This one looks different, but it's the same idea. When you're looking at the number of terms in this problem, we have a term here, and then we have a term here. Okay, it's separated by a plus sign. Well, within those terms, there is a GCF, and that GCF is what they have in common. In this case, it's an entire expression here. Your GCF is y minus 1 quantity squared, so that whole thing. If you take out that y minus 1 quantity squared, all right, it cancels here and you're left with just y. So when I take that out, it has to move out to the front. I have to undistribute it. First term, I'm left with a y. Second term, the same thing would happen. I'm left with a z. So plus right here, z. All right, so that sign comes from there. This won't factor any further. All right, it does expand further, but it doesn't factor any further. And then one method that you will look at is if something has 4 terms, then you want to use what's called grouping. So 4 or more terms, we use grouping. And we want to group these together where you have your 2 terms and your true terms. Now be careful here with this negative sign. It is glued to that a, so this is like plus negative. If I rewrite this, x squared minus xy plus negative ax plus ay. All right. Always, anytime there's a negative lead coefficient, always take out that negative. And so for this one, for this side of this equation, we're going to take out that negative a, and we're left with x minus y. All right. Over here, we're going to take out the x that they have in common. They have an x and an x, and we're left with x minus y. If you get to this point in a grouping problem and your parentheses do not match, then you've done something wrong. So as long as it's factorable at this point in your problem, the parentheses should match. So that becomes your GCF, just like this problem up here. And so we're going to take out that x minus y, and what we're left with is x minus a. Okay. Now the order you write the factors doesn't matter. I could just as easily write x minus a and x minus y. But of course, with your sign, the order inside the parentheses will matter. Okay. For trinomials in the form of a x squared plus bx plus c, where you have a lead coefficient of 1, you need 2 numbers that multiply to C and add to B, or combine to B. Now, the reason this is because factoring a trinomial into two binomials, all right? You'll factor into two binomials. You are essentially reverse foiling it. So we need to unfoil something. Well, when you foil two binomials, and I'm just going to come up with an example here, x plus 7, x minus 2. Those first two terms work together to give you that x squared. And so that's going to be the same case over here. Those last two terms work together to give you that constant, so minus 14, where we get this plus 8. So we have the two numbers working together to give us that number. Those same two numbers are on the inside and the outside, only this time working together as a minus 2x and a plus 7, where we add them together to give us our middle term of, in this example, 5x. And so we have x squared plus 5x minus 14. When I go to factor that and figure out what two things did I multiply, I have to look at how these numbers all interacted together. And so what multiplies to C, your constant term, are those same two numbers, the 7 times 2, that added together to get you your middle term. And so that's what we look for here. I need everything that multiplies to 8, but then also adds to negative 6. So we have 1 and 8, or 2 and 4 are my factor pairs. They both have to be the same sign because 8 is positive. So it's either negative times negative or positive times positive. They add to a negative. So if they're the same sign, they must both be negative. So negative 1, negative 8 is negative 9. Negative 2, negative 4 is negative 6. So this is the one that works. That's the one that goes into my parentheses. And that's as far as you can go. Okay, so work shown is fairly limited, but every once in a while it requires you to write down your factor table. Now, if it has a lead coefficient, just make sure that you're looking for any GCFs first. Always take the negative. If you take nothing else, always take a lead negative. Okay. So this one, the GCF is not just -1, but also -2. They're all even. And so I take that out and I'm left with w squared minus 9w minus 10. So again, watching your signs, making sure you divide appropriately. If you distribute this back, it will get you right back where you started. So it's a good way to check, though not a good way to proceed. So -2 will not go away. We're stuck with it because it's part of this expression. Here we can break this down. And so what multiplies to C and adds to B, just watch your signs. What multiplies to -10 and adds to -9. And so you come up with those different combinations. We could have 2 and 5. We could have 1 and 10. Well, that will never add to 9, positives or negatives. 1 minus 9 gets me, or 1 minus 10 gets me that -10 combination and the -9. So w minus 1, or plus 1, excuse me, and w minus 10. Okay, so every single one of these factors is prime, including -2, then I'm good. And these are from an old textbook, so this no longer applies here. All right, so again, always starting with your GCF here. My GCF is m cubed, which leaves me then with m to the second. When we divide, we subtract, plus 20m plus 100. So same thing as before, this now trinomial needs to be factored. This m cubed will just keep coming down. So I need to know what multiplies to 100 and adds to 20. Well, 100 is 5 and 20, 4 and 25, 10 and 10. Those would add 20. So I have m plus 10 times m plus 10. You could write that all as 1. If you'd like, just do m plus 10 quantity squared. The parentheses are key there. And you could always FOIL to go back in and double check your answers. Now, the order that you write the factors doesn't matter. Up here, negative 2, w minus 10, w plus 10, 1, excuse me, would have worked just as well. Okay, so the order of your factors doesn't matter. And I'm okay if you choose not to condense those. Now, I've mentioned a couple times the signs as far as like, oh, well, that's positive, so I know these have to be positive, and so on and so forth. If you have x plus a number and x minus a number, that will always result in a negative constant. And then depending on what your bigger sign is, that's what will go on to be. So if your last sign is negative, here, your constant is negative, that's what you should look for, one of each. If your last sign is positive, it's going to depend on your second sign. So if it's all positive, then this is all positive. If your last sign is negative, then you're going to depend, or your last sign is positive, sorry, and your second sign is negative, it's going to match whatever that second sign is. And so it's either going to be 2 positives or 2 negatives if that last sign is positive. Okay, so those are just nice little tricks to kind of be familiar with as you're trying to figure out what your values are. Okay, so that leads us into what a lot of Algebra 2 teachers call the AC method, but really something in the form of ax squared plus bx plus c, where a is greater than 1, and so you actually have a lead coefficient. And so that's what we're looking at here with this one. So there's several different ways you can approach these problems, but always keep in mind, again, that we are unfoiling this, right? And so if you distribute, you should be able to check your answer. And so again, just kind of a quick example of that. If you have 2x plus 7 and 3x minus 1, then these two numbers here, that 2x times 3x, are what result in that 6x squared at the front of your trinomial here. And then we have 2x minus 1, so plus 2x times negative 1. Those outside numbers working together here for an x term or a linear term in the middle. Same here, the 7 times the 3x will give me another x term. I'm going to end up with minus 2x and plus 21x. That will then combine together to give me 19x's. And then those last two terms, I'm going to take the 7 times the negative 1 to give me my constant term of negative 7. So I put that in the wrong place. 7 times negative 1, so that I have that negative 7 in the back there. And so because of how those interact and work together, we can break this trinomial down. This front term, for example, is going to be 2 things that multiply to give me 6w squared. Well, that can be 6w and 1w, or 2w and 3w. The back number, that constant, is the product of those 2 back numbers. And so to get 1, well, the only way to get 1 is to do 1 times 1. And so that has to go in the back. So now it's just a matter of when I take these inside 2 terms and these outside 2 terms, those are going to combine in the middle to give me my middle x value term. So right now I have 1 and 1. I need that to get to 5. All right, so a combination of these numbers multiplied with my 1s should get me 5. Here's where knowing the signs comes in handy. Because these are both positive, I know that these also both need to be positive, because that's my rule. If it multiplies and adds to a positive number, it's going to be a positive value. So that helps even more. That means that all of these have to be positive values. So 6W, 1, 2, and 3 are all positive. Well, in that case, the only thing that then adds to 5 is the 2 and the 3. So 2W and 3W here will give me 3W and 2W. Those add together to 5W, and that checks out. You could always FOIL completely out to make sure. So these are my complete factors. 2W plus 1, 3W plus 1. Now there's several other ways that you can approach these problems. We'll go over some of those together in class. Okay, but the basic idea is that we're looking for combinations so that when we unfoil this, we get our two binomial factors. All right, so same concept here. If I break this apart into the product of two binomials, because this is 2, my only options are 2 and 1. It's a prime number. So 2x and 1x. All right. Back here, though, with 6, I once again have the combination of I can either be 2 or 3, or it can be 6 and 1. So I would need to figure out if there's a combination for both of these. Now, because this is negative, I have 1 negative and 1 positive. And it should multiply here and here. It should combine to give me a negative 3 when I add those together. Okay. So figuring that out, well, if this is 6, then that is 12. And this is 1, and that's either, that's negative 11. So that doesn't work, right? And so that can go away. And so 6 and 1 didn't work there. Well, maybe 6 and 1 will work here. Well, right away, red flags should go up in your head. This is not, these already have a common factor, and so that won't work. And so that's another way to kind of expedite this process. You're never going to put anything that has a GCF with something else. So as I move to 2 and 3, the 2 will never go with the 2. So 2 would have to go here, 3 would have to go here. I can't put a 2 here, or they have a GCF. Well, 2 times 2 is 4, 3 times 1 is 3. There's no way to combine 3 and 4 with addition or subtraction to get negative 3. So nothing has worked. All right. When there is nothing, that means this doesn't factor. And any number that doesn't factor is called prime. So any trinomial that doesn't factor is also prime. Okay. All right, from there we get into special products. So we have difference of squares and sum and difference of cubes. And so let me switch screens here for a second. So here's kind of where we're at in our process. So you're always looking for your greatest common factor first. Once you know your greatest common factor has been taken out, then it's a matter of how many terms do you have. So do you have 2 terms, 3 terms, or 4 terms? We've gone through 3 terms. All right, those are trinomials. We haven't talked about like perfect square trinomials or some of those other patterns, but we've gone through how to factor each of them. 4 terms is grouping. So we did one example where you have to group, take out that GCF and group. So these two are really closely related. There's a way to do 3-term AC method where you use grouping as well. So what we have not talked about yet is 2 terms, and there's only 2 types of 2-term problems after you take the GCF. They either have to be difference of squares, or they have to be difference or sum of cubes. Now, sum of squares does not work. I'm not sure why that's on this flowchart. I've never even noticed that before. Okay. If nothing can be done, then it is prime, right? So these are the 2 we're going to look at, is sum and difference of cubes as well as difference of squares. All right, so a special product is when you take your a times your a and you get your a squared, but then you get minus ab, and then you get plus ab, and then you get minus b squared. So what happens with these same 2 terms with different signs is that these middle 2 terms add 0, they go away. And so anytime you're factoring a difference of squares, you know what those factors will be. You know the factors will always be the roots of these 2 numbers 1 plus and 1 minus. Now the order of the plus and minus doesn't matter, but 1 will be plus and 1 will be minus every single time. So that makes these go fairly quickly, right? So square root of x is x, so that has to be our first term. Square root of 16 is 4, 1 plus, 1 minus, and you're done. Now, if you get confused on this, you can always rewrite this as x squared plus 0x minus 16 and use a trinomial method of factoring. All right, but the pattern's always the same. Square root of 49 is 7. Square root of a squared is a. Square root of 64 is 8. B squared is b. So 7a and 8b for both of them. 1 plus, 1 minus, and you're done. Okay, if it has a GCF, you still need to take that out first. If it has a higher exponent, we still, as long as it's a perfect square, take its square root. Now make sure you factor completely. Square root here is 4x squared. Square root of 1 is 1. We have 4x squared and 1 again. 1 plus, 1 minus. Now sum of squares is prime, so that factor is done. Difference of two squares, though, the fact that this is also a perfect square means that this one factors again, difference of squares. And so square root of 4x squared is 2. And so we have 2x minus 1 and 2x plus 1. So this one is completely factored now. All right. And then you have your sum and difference of squares, which is unfortunately just kind of a pattern that you have to memorize. Sum of squares is always prime. So that's something else that you'll want to memorize. So it can't be factored further. And that's just what you would write, or you would write prime. Sum and difference of cubes, we don't use this book anymore, follows a certain pattern. And so same idea to start with, we're going to look at the roots. So if these are both perfect cubes, we're going to take that root of that, a plus b. All right. If you take an a out of an a cubed, you're left with an a squared. And so think about distributing here. A times a squared would give us a cubed. Same with our b back here. If I take a b from a b cubed, I would be left with b squared. And b times b squared would give me b cubed. Now the problem is this has no middle terms, so I want this to have no middle terms as well. Well, here I'd have an a squared b, and I'd also have an a b squared, and both of those need canceled out. So the way that that happens is right here in the middle, I'm going to do minus, and then the product of the two roots. And so these two roots here. The pattern with the signs is that this sign was the same. This sign is the opposite. The last sign will always be plus because it'll be either positive times positive or negative times negative. So same sign here, a minus b, take your roots, square the first term, so a squared, product of the two, so plus ab because it's the opposite sign, square the last term, plus b squared. So it's one of those patterns that you do kind of have to memorize to get there. Okay, so cubed root of 8 is 2, cubed root of x cubed is x, same sign, cubed root of 1 is 1. All right, square the first term, so 4x squared. Opposite sign, product of the two is 2x, square the last term. That trinomial will never factor further. All right, so keep in mind that this is 2x squared here. I squared my first term. This is negative 1 squared. And this is 2x times 1. Okay, so ignoring the sign on that one, we use the opposite sign. Okay, so your a is the cubed root of 8x cubed, which is 2x. Your b is the cubed root of 1, which is 1. Okay. And the last ones you'll see, and I know this is getting a little lengthy in the video here, but they're quadratic form, quadratic type. So anything after your, or that is attached to the square is your quadratic term. This is your linear term, and this is your constant. All right. So when you're dealing with problems like this, you can do it one of two ways. You could absolutely square this, distribute that, combine like terms, and then factor. Okay. Never distribute a square when there's addition or subtraction. So into multiple terms. All right, for here though, we could, because if you see this GCF is m plus 2, we can take that out. And so the m plus 2, let's just call it x. And this is a method that in calculus they'll call like U substitution. So x squared plus 2x minus 3. All right, well this factors like a regular trinomial. This becomes x, and what multiplies to negative 3 and adds to positive 2, we have plus 3 minus 1. All right, so that's factored, but my x was m plus 2. So I want to go back in and replace both of my x's with what it actually is. So m plus 2 plus 3, and then m plus 2 minus 1. So replacing that m plus 2 with the x there. Last thing here I do is just add my like terms. That's the 5. And that would be my final answer. Okay. Again, you could always do m plus 2 times m plus 2 plus 2 times m plus 2, distributing that, minus 3. Combine all like terms and then factor. That would work just as well. Okay, with problems like this, you don't need to do anything so long as this first term, the exponent is double the exponent from the middle term. All right, from there, we're just going to factor it just like we always would. It's going to break down so that you have that middle term as your first term in both of your binomials. All right, because then when you add them, they will add to the middle. When you multiply them, we add them together. N plus n is 2n. So this will start as x to the 4th and x to the 4th. All right, that combines, that adds together to x to the 4th, and it multiplies together to x to the 8th. From there, we do it the same way. What multiplies to negative 6 and adds to negative 1. So we have 6 and 1, or 2 and 3. 2 minus 3 is negative 1, so that's our combination. Plus 2 minus 3. All right. Neither of those are difference of squares or sum or difference of cubes, and they're two terms, so they do not factor any further. And that's your final answer. All right. Let me know if you have any questions, but that is factoring in a nutshell. Thanks.